and friction.
Hey, are you doing things at your own place? You must come across some difficulties. I want to remove those difficulties first. There must
I have two questions.
Okay, so let us first solve those two questions.
Okay.
Uh,
अच्छा, ये again conceptual question है दो.
okay.
So पहला सवाल ये है, which graph correctly represents the vertical speed of a dropped object with respect to time?
That's right. But you see, Fatima, there are some ways you can directly send those questions by some means on the Zoom. But if you can just tell me how the graph look like, I can explain you. Okay, give me the question. I will give you the correct graph.
Okay. The vertical speed of a dropped object with respect to time.
The vertical speed
of a dropped object
vertical
with respect to
speed of a
dropped object with respect to time.
With respect to time. So you had to find a graph between time versus velocity.
Yes.
It's a particle being dropped like this, right?
Yes.
And acceleration due to gravity is downwards, right?
Yes.
Velocity time graph slope gives acceleration.
Yes.
So velocity time graph slope gives acceleration, but that acceleration here is constant.
Right.
Acceleration vertical g is constant. That means velocity time graph slope must be constant. Means it must be a straight line. So graph must be like this. Or it must be like this if they define g to be positive, then like this. Either this or this.
Yes.
Which one?
Top one.
Top one. That means he is supposing that g is positive. I always suppose it to be negative. Anyway, I will explain once again. I will explain. See, look at this. Velocity time graph gives acceleration. Slope of velocity time graph, slope. So if you plot a graph between time versus velocity, particle falling down, g is constant. G is constant. That means acceleration is constant. When the slope is constant, what is the shape of the slope? That means it must be a straight line to have a constant slope. So what was the initial velocity when it was being dropped? 0. So why the graph should start from the origin? Because at time t is equal to 0, velocity is equal to 0. So graph should start here. So should I make a curvilinear line? No, because that will give variable velocity, variable acceleration.
Yes.
I have to make a straight line so that the slope of that straight line is acceleration. Like this. The slope of this line is acceleration. If you find tan theta of this, tan theta, that's perpendicular by base. Perpendicular is read from here. That is change in velocity. Base is read from here. That is delta t. That is acceleration. That is g. Okay?
जी जो असल में जो मैंने जवाब लिखा था ना, I did a negative slope downwards, but in the first quadrant.
But that should have been like this, right?
Yes.
if that is also a correct
Right.
answer. But has he written G to be positive or negative?
Oh, positive.
If he has written positive, then this. If he has written negative, then this. It is for him to decide, right?
इनिशियली मैंने यही किया था ना, जैसे नीचे वाला आपने ड्रॉ किया, लेकिन पहले क्वाड्रेंट में ड्रॉ किया कि मैंने नेगेटिव स्लोप बनाया था, लेकिन फर्स्ट क्वाड्रेंट में.
Have you
So
like this?
yes, that's what I thought, but
No,
ऐसे नहीं
that
था.
is yes. You are right. You are right. You are right. That is when at time t is equal to 0. What is the initial velocity here?
Oh yes, that's okay.
This much. So at t is equal to 0, you are giving some velocity.
जी.
At t is equal to 0, you are giving, but you are just dropping it from the initial position. T is equal to 0, you are just dropping it or releasing it. That means the initial velocity is 0. But if you throw it upwards
Yes.
with initial velocity v0, right?
Yes.
Then your graph is correct. Acceleration is the same as g.
Yes.
Then your graph is correct. Okay. Any other question you have?
Another just conceptual question.
Okay.
So, relative to the typical dropping parachutist, one who thrusts himself downwards on exiting the airplane, so you ignore air resistance and assume both parachutists open their parachutes at the same time, तो उनकी acceleration और velocity कैसे compare होगी?
That's right.
Like
Yes, yes. Yes.
जी.
हाँ,
Oh, okay. तो वो कह रहे हैं कि कंपेयर करें कि जो अपने आप को नीचे इनिशियल वेलोसिटी के साथ जोर से फेंके, लाइक कोई इनिशियल वेलोसिटी इज नॉट जीरो वर्सेस जब वो हाली ड्रॉप हो जाए इनिशियल वेलोसिटी इज जीरो, तो उनका एक्सेलरेशन क्या होगा जस्ट बिफोर ओपनिंग द पैराशूट और यस
just before.
जी.
Okay. Fatima, can you repeat question once again?
Yes. So compare the acceleration and velocity of a parachutist who drops from the plane versus who thrusts himself from the airplane.
Who
Just
drops,
before opening the parachute.
Who drops and who thrusts. Okay.
Yes. तो इन दोनों के acceleration और velocity compare करने हैं before वो.
Okay, okay, okay. And here possibly they will open the parachutes.
Yes.
Before we have to compare their accelerations. Okay. Fatima, look here. Acceleration, the decision of acceleration is not for them. You see, if he says thrusts, look at this. The decision of the acceleration has been taken by the earth. It is none of their job. So both will fall with the acceleration due to gravity g.
Yeah.
Is that right?
Yes.
Both will fall with the acceleration due to gravity. It has nothing to do with the aircrafts or with the bodies themselves. It is decision will be taken by the earth. Both will be pulled down with the same acceleration. And that acceleration even does not depend upon their masses. Gravitational acceleration is independent of mass, right?
Yes.
So whether one may be fat person, other may be a thin person, both will have the same acceleration due to gravity.
Yes.
So we did one part. So far as the velocity is concerned, initial velocity, after some time, the one who thrusts himself downwards will have more velocity because it is starting with some initial velocity. It is not starting with initial velocity. So if his final velocity will be v0 plus gt, and v is equal to this is 0 gt, and its velocity will be v dash is equal to v0 plus gt. He is starting with some initial velocity, so his velocity at any time after will be more than his velocity. I don't know exactly how the answer is there, but it is what I can think from such a huge distance.
Yes. No, the exact answer I say no.
You can think properly yourself looking at the question, but I am explaining you acceleration is same for both. Reason is
Yes.
acceleration, the decision of the acceleration is not their decision, it is the decision of the earth, which is same for the both. So far as velocity is concerned, velocity increase will be uniform for both. Increase in velocity will be there, uniform for both. But he has started with some initial velocity. He has already something in his pocket. So whatever he gets in addition will be added to what he has already in his pocket.
Yes.
And he has only something in addition and nothing in the pocket to start with.
Right.
Am I right?
Yes.
Okay. Anything else?
No, not from this chapter.
Okay. Any question from projectile motion?
No, projectile motion, I think I understand well now.
Projectile motion you have done?
G.
Okay. Any question you are held up with?
Not really from the practice problems yet.
Okay. I'm getting the book in a few days of time from Delhi. My daughter is there. She is getting the books from the Delhi. I will be getting them in about a fortnight.
नहीं वो हरीत के मैंने इस संडे को ही दे दी थी हनीफ भाई को.
Hanif ne kaha कि it is not possible to send them from here. It's very difficult, or it will take a lot of time, or the shipping charges may be higher. So I dropped that idea. I'm getting them from Delhi, no problem.
Oh, oh no, sorry.
No, why should you be sorry for what for? No, it is not good. Why should you be sorry? No. I need those books. I'm not getting those books only for you. I need them for myself. Maybe there'll be more students from US who need my help, and I'll be willing to help them, especially those from Pakistan, from Asia, Asian students, Muslims.
अभी इधर कोई नहीं है इतने अभी इंडियन में हाल ही मैं ही हूँ.
ठीक है. आप तो अपनी हो ना, आप तो अपनी बेटी की तरह हो, बाकी उनके मैं कह रहा हूँ.
Thank you.
Okay.
अच्छा अब I did practice problems. So अभी तक बुक में आसान ही है, अभी मुश्किल नहीं आए इनमें.
Okay.
क्योंकि MCAT के लिए काफी बेसिक है.
So I have already told you how to do things. First is what I have the experience for past experience with students. First, you go through the chapter.
Yes.
Go through the chapter. Second, then do solved examples.
Yes.
Then go for simple problems, simple ones.
Yes.
Then level second, it is level first. Then level second, then level third, then finally level or आहिस्ते आहिस्ते बढ़ जाएगा. And finally you can solve any question.
Right.
So what we are doing?
I am at step 3.
Okay, that is better.
Yes. Step 3. Okay. So फिर अभी जो next topic है वो है Newton's law of gravitation.
The Newton's laws which I discussed with you, have you done their problems? Have you gone through that? Have you done?
Yes. जो solved problems है वो कर लिए हैं.
First of all, that will give you a lot. That will give you an easy approach. When you are doing solved problems, it will give you some feel easy approach and easy to do things. You'll feel better with them. And how many days it will take? It will take mostly one day. So you are not wasting any time with them. So
Yeah.
when you cover them all, then you go to questions which are simple, level 1 questions.
Right.
Maybe objectives, having those options. Go through
Right.
them one by one. If you are not able to
No,
solve any of them, then you can ask me. This question is a little difficult. And then you go to the level 2. If you have any problem there also, you can ask me. Maybe you are doing 50 questions a day. If you can do the 50 out of 50 questions, maybe you are not able to solve even 10 questions, maybe 15 questions, maybe even 20 questions. You can ask me one by one. I will discuss them all with you. I have no problem doing questions. I teach physics from sophomore level.
जी अभी मैंने जो लॉज ऑफ ग्रेविटेशन है उनके मैंने सॉल्व्ड एग्जांपल्स खत्म कर लिए सारे.
ठीक है.
तो वो आ गया, लेकिन फिर वो जो लेवल 1 क्वेश्चंस है वो चैप्टर के एंड में है ना, तो वो तब तक मैं नहीं कर सकती जब तक चैप्टर ना खत्म कर लूं.
चलो ठीक है. ओके, सो व्हाट यू वांट मी टू डू राइट नाउ?
Just law of gravitation and अगर टाइम हुआ तो फ्रिक्शन.
Okay, first of all, law of gravitation.
अगर आप चाहें आप मुझे कोई, आपके पास कोई टेस्ट है, कोई ऐसे कुछ जिससे आप मुझे लॉ लाइक जैसे न्यूटन्स लॉज या ऐसे कुछ से टेस्ट कर सकते हैं?
I can do. We have many sources here of testing this, that, and that. But I don't know American system. I don't know what tests they here. The tests are very difficult. Here, students have to go through a very tough competition. In America and in Europe, we don't have such a competition as we have here in India, because here colleges are very limited, and students are very large in number, in thousands, in tens of thousands. So the entrance examination is tough here. If you want me to design questions for you, I have no problem. Let that book come to me, and then I will frame questions for you.
और असल में मैं ये भी कर सकती हूँ कि एक जो कंपनी बनाता है ना टेस्ट, उन्होंने ऑनलाइन प्रॉब्लम सेट्स रखे हुए हैं ना, तो उनको मैं खरीद के, वो ऑनलाइन है, तो मैं आपको पासवर्ड सब कुछ दे के ना, तो आप वो एग्जांपल्स भी देख सकते हैं. वो भी हमारे लिए
that is very good. If you have online question testing, then you can send them on Zoom. This Zoom has that facility. You can send those questions, and I can solve them for you.
Okay, ऐसे करती हूँ.
You can WhatsApp those questions.
Okay.
I have WhatsApp. I do have WhatsApp now. I was not having it earlier. Then this Gashu, we call him. We call him Gashu, but he is Hanif. He has asked me for this WhatsApp, and then he is sending me message on the WhatsApp. You can send me questions on WhatsApp. Then I can solve.
ईमेल है आपका? आईडी ईमेल है आपकी?
आईडी भी है, ईमेल भी है मेरा. आपको मैंने दिया है.
नहीं, वो जो WhatsApp का आईडी के WhatsApp पर नंबर होता है?
वो नंबर पर आता है वो 9696202250.
ठीक है, मैं अभी ऐड कर लेती.
Then I have my email is physicist.
जी. Nazir Tantray
Nazir Tantray @gmail.com. You can send them here. So it is better to send them here so that I can download them.
Okay.
If I download them, then I will work them out and show them one by one question. Now, what you want me to do for the time being? Newton's law of gravitation?
Yes, please.
Okay, I will give you the Newton's law of gravitation. Okay? See here. According to Newton's law, two objects of mass is m1 and m2. Maybe sun, maybe star, maybe earth. This is earth, this is sun. Maybe this is mass of 10 kg, this is mass of 20 kg. Maybe this is something in the space, maybe this is another thing in the space, provided both have masses, right?
Yes.
And center to center distances are. Then Newton says that these two objects, they attract each other along the lining joining them, right?
Yes.
This is the direction of force. This is the force F12. This is force F21. F12 means force on one, mass 1, created by 2. This
Yes.
F21 means force on 2,
Created by 1.
1. So according to Newton, this F12 is equal to minus F21, obviously because they are opposite, right?
Yes.
That is why they are negative of each other, is equal to G constant m1 mass m2 mass by r square. That is all.
Yeah.
That is all. Gravitational force between two objects is proportional to the product and inversely proportional to the square of the distance with a multiplied constant g, where g value is 6.67 to 10 raised to power minus 11 Newton. When you multiply this in meter square, kg square per kg square. This is the unit, right? So this is the value of the g, capital G, and this has been calculated by scientists. There's no problem finding it now, or if we want why it is so, it has been calculated.
Yes.
Basically, two objects of any mass attract each other. This mass attracts this mass, and this mass attracts this with force maybe F12 and it is F21, and we get this F1, this force, and their magnitude is the same. So what is the force? G.
Force is G
M1 M2 by
R squared.
R square. Now, what is the direction of this force?
Direction.
If I put this law into vector form, in vector form is like this. This is mass M1, this is mass M2. Suppose this is R, you take this direction or unit vector direction, right?
Yes.
Now please tell me, what is this force F12 and what is this force F21? This F12 is G M1 M2 by what square?
R squared.
R square. So what's the direction of this force?
Positive direction?
Yes, it is this direction, right?
Yes.
So this direction coincides with what?
So X on the
This is R unit vector. This direction coincides with what?
The x-axis?
You call it x-axis, okay, but it's R unit vector.
Are you?
Unit vector means it is magnitude is 1. It only gives the direction, right?
Right.
So you can also write it M1 M2 by R square. This R unit vector is, it is vector by its magnitude, no?
Yes.
Any unit vector is vector by its magnitude. That's the definition of a unit vector. Vector, if you divide a vector by its own magnitude, it becomes what?
A direction?
It becomes a unit vector.
A unit. Does that give the direction?
That only gives the direction, yes.
Okay.
So what is this F12? G times M1 M2 by R squared or?
Yes, R squared and then R unit vector.
R square into this R.
Yes.
It's what?
Oh. R squared. R cubed.
R cube. And their R vector. This is one more form of Newton's law. If you want to put in vector form, if it is R square denominator, then it is r unit vector here. If it is r cube in the denominator, then it's r vector here. Because a unit vector is just written by vector r by its magnitude r. Okay?
Right.
What is F21? This one.
So that's minus r unit vector
Yes, M1, M2 by
over
r
r squared.
r
Or
square. You can write that
r.
also into r unit vector. Same thing, but with a negative sign.
Mhm.
This is what you call as Newton's law of gravitation. The force between two objects. Okay, I will give you one more example. Suppose this is a mass 2 kg. It is mass 7 kg. And I am asking you what is the force between them. Your answer should be F. Okay, that force is on this, that force is on this, but direction is opposite. I want to find the magnitude. That is G M1 M2 by R square, right?
Yes.
If you want to put it a vector, then you have to multiply by R unit vector.
Yes.
So it is G is 6.67 to 10 raised to power minus 11. M1 is 2 kg and M2 is 7 kg. Divide by R square if it is, okay, 2 meter, 2 square. Calculate the value, get the answer in newtons.
Yes.
That's all.
Mhm.
That's how it works.
Indeed.
Okay. Now let me tell you one more thing. In what form in your books is given this gravitation law?
Um.
Can you give me the last equation that you have in your books?
Yes. F gravity equals capital G times m capital lowercase m all over r squared.
M1
Yeah, m1 m2 over r squared times capital G equals F force due to gravity.
That's all. That's simple. Okay. Had there been any other form, I would have derived that also. But now it is a simple form. Okay. Let us stick with it.
They also did weight is equal to F due to gravity.
Yes.
And then they derived G lowercase g equals capital G times m over r squared.
Okay. That's acceleration due to gravity of Earth. Okay. I will derive that. Acceleration due to gravity.
Yes.
I will derive this for you. Okay. Now see, it is Earth with radius r. Okay. Mass m. Earth. I want to find, here is an object small mass m, right?
Yes.
And how much distant it is from the center. Okay. That's all. Can you tell me how much force is on this little mass?
It's
F
F equals
G
G
M.
m1 capital M lowercase m all over r squared.
Is that right?
Yes.
This is the force on this little mass.
Yes.
Can you tell me what is the acceleration of this little mass?
Acceleration equals force all over lowercase m.
Is that right? Force that is acts on this mass divided by mass of the object, not mass of the Earth, mass of the object.
Yes.
Whosoever gets accelerated, you have to divide by that object's mass. So you are dividing that object's mass, right?
Yes.
So what is this? G m small m by r square, right?
Yes.
That is this. Divided by.
Lowercase m.
So you are
Object.
substituting for gravitation. For this m gets cancelled, right?
Yes.
So what is acceleration?
G m all over r squared.
But now this is acceleration due to gravity. Therefore, we call it g. We have been calling it g for quite some time now.
Yes.
But here I write it a so that it, because you are already familiar with this a as f by m. If I would write g is equal to f by m, you may get confused. See, I'm writing something new. I told you it is the same a, but because of this acceleration is caused by the gravity of Earth, that's why we write g. So it is g m by r square. This is a formula any body falling to the ground is with this acceleration, because anybody falling towards the earth, maybe they have different masses, but they will fall with the same acceleration due to gravity.
Yes.
Why so? Can you tell me?
They will fall with the same acceleration due to gravity no matter the mass.
No matter what the mass is, because there's no mass of the object here.
Right. It
In
only
this,
matters.
it only matters what is the mass of the earth. That's why I told you that when the two persons falling from the aircraft, they will have the same accelerations. Why? Because the acceleration does not depend on their mass. It depends upon the mass of the earth, which is same for both, because earth is pulling both the downwards, both of them. Do you understand that?
Yes.
Okay, now by your own common sense, can you tell me what's the acceleration of the object here on the surface of the earth?
On the surface. Would it just be the lowercase g? It's still
Okay, lowercase g. Okay, you write g r here because it is, acceleration due to gravity is a function of r. Therefore,
okay.
or here. What's g on the surface of the earth?
It'd be capital G times
Good.
mass of Earth, and whatever the radius is between that object and the Earth. So the radius of the Earth.
That's right. Because distance between the object and the earth, that happens to be the radius of the earth.
It's because it's from the center of mass. So r, lowercase r is always center of mass.
Yes.
Is in
Center of mass of this little object, it is the object itself and the center of the earth. You take the distance between the two.
right.
This is the answer. If you want to put it in some other, if you want to put it in some other form, Fatima,
G.
it is g by r square. If you write something for mass, if I suppose the earth is a sphere of radius r, so I can write it as mass is as density into volume 4 by 3 pi r cube. No?
Yes.
After all, what is the mass of the earth? What is the mass of the earth?
Yeah, like the mass of a sphere.
What is the mass of the earth?
Like the mass of a sphere.
Yes, that's the mass of the sphere, but for that you have to find the density and this, okay?
Yes.
If I put it like this, it is 4 pi
r cube.
Yeah, okay. G rho r by 3. Because it is r square in the denominator, r cube here, so it will remain r in the numerator, right?
Right.
This is also a formula for acceleration due to gravity on the surface of the earth. Isn't that?
Yes.
Okay. So what you found is that acceleration due to gravity on the surface of the earth. See, it is earth. You want to find acceleration due to gravity here. It is nothing but g is equal to gm by r square, or 4 pi g rho capital R by 3. Is that right?
Yes.
We derived this, no?
Yes.
By substituting m, we derived this. Okay. Now, if you substitute the values, you know g, you know m, you know r. Mass of the earth is well known. G is well known. Radius of the earth people know. You don't need to calculate. You don't go and calculate it now. It has already been calculated by the people. So if you substitute these values, 9.8 meter per second square. So anybody falling to the ground in the vicinity of the earth, will fall with what acceleration?
Acceleration due to gravity on Earth 9.8.
Is that right?
Yes.
Okay. Now, can you tell me one more thing? What is acceleration due to gravity? Okay, third point is, let me suppose, again it's the Earth. I want to find acceleration due to gravity here at this point. It is R. What is acceleration due to gravity here? GR is equal to GM by small r square. Have we done this? Yes. Just now when I put mass, small mass here and capital mass here, I found the force between these two, and then I found the acceleration on this little mass. That was this.
Yes.
Okay?
Yes.
Can you plot a graph? Can you plot a graph between acceleration due to gravity and R?
Acceleration due to gravity.
Yes.
GY R. So
If R is 0, what is acceleration due to gravity?
Acceleration due to gravity. It decreases as radius increases.
That's right. That's right. That's right. It decreases as radius increases, but the graph cannot start from the center because you don't know what is acceleration inside the Earth. The formula that we have right here is from the surface of the Earth because the object is outside the Earth. So this formula is valid where? Where is it valid? When R, this R is greater or equal to capital R, means the object is outside the Earth.
Yes.
The object must be beyond R, beyond this capital R, means it is outside. Therefore, this formula can be used only when R is greater or equal to R. So if it is R equal to capital R, so graph is starting from here. The graph is here like this. You said rightly that acceleration due to gravity decreases as we go away because of this GR is inversely proportional to R square. But what about the graph here? What's the graph from here to here? For that, you have to find acceleration due to gravity inside the Earth, no?
Yes.
When you find acceleration due to gravity inside the Earth, then you can find the graph from center to the surface to the radius of the Earth, up to here. You can find a graph from here to here only when you know the equation from center to the surface. How to find the acceleration inside the Earth? Suppose somebody is inside the Earth. What is his acceleration due to gravity? Do you understand that?
G.
Now my question is, what is acceleration due to gravity here at this point? Can you tell me? Okay, now I will tell you something. With this point, you draw a sphere. You draw a
sphere here.
Sphere. It is this mass. It is this mass of the sphere. This one.
Yeah.
Which creates acceleration due to gravity here at this point. Again, you have the formula G is equal to Gm by R square. You have this general formula. But now this mass is not the mass of the whole Earth. This mass is m bar, that is mass of this inside sphere. So if you want to find acceleration due to gravity here, it is not contributed by this mass, this mass, this mass, this or this or this or this or this. It is contributed by the mass in this core, in this inside core, which is a sphere with the radius of equal to this. That you have to remember, right?
Yes.
You understand that?
Yes.
Whenever you are inside the Earth, the Earth which is above your head will not contribute to acceleration due to gravity. Neither this part nor this part. It is only this sphere which will contribute. So I will derive it like this. GR is equal to G by small r square. What is m dash, mass of this little sphere?
Rho 4/3
Rho 4 by 3 pi small r cube, right?
Right.
Small r cube, because the mass of this. Right. Small r is the radius of this.
Yes.
So it is r here. So what should I write? GR is equal to G rho 4 by 3 pi r. No? Can you tell me what is this rho?
Yes.
What's that?
Is it a constant?
It is constant.
Rho
Definitely
is dense.
it's constant. It's supposed to be constant. Maybe it is not, but here it is supposed to be constant. Okay. Tell me that.
So the rho for Earth?
Okay, rho for Earth. What's the rho of the Earth?
Mass over density.
Let me write what it is, but let me see whether you can understand yourself.
Mhm.
Yes. Have you understood?
Yes. So rho is just mass over volume. But we did volume of Earth. We need density of just the sphere. So it'd be little r cubed.
I took the density of the whole Earth, but that's anyway the density anywhere inside. If it is supposed to be constant, right?
Right.
So what is important is I took the total mass and total volume.
Mm-hmm.
So it cancels off. So what is the formula now inside the Earth? G M, right?
G
By R cube
times
into
load.
small. This is the formula. When R is less equal to capital R. That means when the body is inside the Earth. That's why I wrote less equal to R. The particle can onto the surface of Earth or it may be inside. From center to the surface, this is the formula. From surface onwards, this is the formula.
Yes.
No. That is the formula that I have already told you.
Mm-hmm.
Do you have better feeling of this now?
Yes. I have one question.
Okay.
So the density we found of the whole Earth.
Mm-hmm.
So it doesn't have to be the density of just the sphere.
Mm-hmm.
It's still within the Earth. Is that why we find density of the Earth and not the sphere?
Okay. You say the density, what we wrote, the density equation or density formula, is that the density of this little sphere inside?
Yes, it's not.
It is not?
I think it's the whole Earth's density.
Okay, that is good. That is just like a typical thinking of a okay. I will explain you. No problem.
Oh,
It is quite natural for you to say that, well, I found the density for the whole Earth. And then I need the density of this little part, right?
right.
And what is your question of that what I should say? Question raised by an inexperienced mind. I am suffering from cold.
I am too.
Okay, now you want to get the answer to this question, but I had to do too many things about this. Okay, let me answer you the question. I took the whole mass of the Earth, but at the same time, I took the whole volume, right? Didn't?
Yes.
Suppose there is water, right?
Yes.
What is density of water? 1000 kg per cubic meter, isn't?
Yes.
If you want to find density of water, how you find the density of water? You take some water from here, right?
Yes.
Some water, find its weight, find its mass, find its volume, this little water, and divide.
Right.
That will be 1000 kg per cubic meter. Answer will be that. Suppose you take larger volume.
Mm-hmm.
You take
Larger volume.
larger volume when you take, that will have larger mass.
Yes.
And divided by larger volume, it will be the same 1000 kg.
Yes.
If you take little part of it, little part will have little mass, little volume. Division will be the same.
Right.
10 by 10 is the same as 100 by 100 is 1000 by 1000. So whatever mass you take, you divide by that volume. I took the whole earth, but I divided. You understand that?
Yes.
I took the whole earth's mass, but I took the whole volume. If I don't take the whole earth's mass, I take a little earth, this much of earth. Right?
Yes.
And I will find its mass, but I will divide by its little volume. That will be the same as rho. Because we have assumed the rho is to be uniform. So if you are finding the density of the whole earth, it is the same as density of any part of the earth. Why you bother?
Right.
Why you bother?
Yes. Got it.
You understand that?
Yes.
So finding the density of something does not mean that you you have to find part of it. You have to find the volume of part of it, mass of part of it. Then you divide. You will get the answer.
Right.
Right now.
Yes.
Okay. Now, what we have learned is that it is Earth, and Earth's radius is r, and here at small r, the acceleration due to gravity, gr is equal to gm by r cube small r. What is, by this equation, what is the acceleration due to gravity at the center? Yes. What is the acceleration due to gravity at the center?
The center.
Yes.
There is R. So would it be the same equation? No, we don't have any more radius. 0?
Finally, you come to the right answer. I don't know whether you look at in the books or you
no,
just, huh?
No, I'm not looking. I'm not looking.
Okay. Then tell me how you know that acceleration due to gravity is 0 here.
Because there's no radius.
Because it is no?
Radius?
No. Radius of the earth is there. But this formula tells you that if this small r is 0, then gr is 0. Small r is here. So acceleration due to gravity here is this. If you decrease r, decrease, then you here. That means in this formula, what you have to put r small r equal to? 0, then gr is 0. You understand that? So here the acceleration due to gravity is a function of small r. Small r ज़्यादा होगा तो acceleration due to gravity ज़्यादा होगा. ये तो constant है radius of the earth. So it's a function of small r. So if you get down to the center, small r is 0. So acceleration due to gravity is 0. So I will write acceleration due to gravity is 0 at the center of the earth. And from the center, if you go away towards the surface, what happens to this acceleration due to gravity, according to this formula?
It increases.
Good. It increases linearly, no?
Yes.
Linear, because it's a gr and r is a linear equation. G and r is a linear equation. It's a linear equation, just linear equation. So acceleration due to gravity increases linearly up to the surface. And from surface onwards, it decreases. That you know. Yes. As 1 by r square.
Yes.
No, you don't understand that.
No, I understand.
You see? Just here. Don't you know that acceleration due to gravity, it decreases as 1 by r square from the surface onwards.
Right.
Surface के बाहर तो decrease हो रहा है ना?
जी.
Because r square denominator की वजह से.
Yes.
तो अब हमने ये जो ग्राफ खाली था ना यहाँ से यहाँ तक वो भी कंप्लीट किया हमने. So now it is a straight line up to here. From center to the surface, acceleration due to gravity increases as r, proportional to r. So equation is linear. Graph is a straight line. So from center to the surface, it increases as r linearly, then it decreases 1 by r square. That's the
Yes.
answer.
ठीक.
You understand? So we have completed the graph. So we have found everything about the acceleration due to gravity, how it changes from center even up to outside. So it is something like this. R versus G. From center to the surface, it's R equal to R. What's the acceleration due to gravity on the surface? Here, what should I write here?
At
G,
that, 9.8
yes,
for gravity.
Gm by R square, that is 9.8 meter per second square. And from surface, it is the surface. R is equal to R is here. It is the surface. What happens now onwards?
It decreases exponentially.
It decreases not exponentially, hyperbolically.
Hyperbolic.
Hyperbolically. Hyperbola. It's the hyperbolic function.
Right.
Okay.
Yes.
Fatma, it is sufficient for today because I'm not feeling well.
No, it's okay.
Okay. Let's stop the meeting. Let us stop the meeting.
Okay, thank you so much.
It's all right. No need for thanks.
Thank you. Losses.
Okay.